Okay, let me ask you guys a question. So imagine you're climbing Mount Everest. So this is Mount Everest and it's governed by this function. You are currently at this location, 3 across in the negative direction, 4 in the y direction. This is your x direction, this is your y direction. So -3 would be 1, 2, 3 and 4 up in the y direction. 1, 2, 3, 4. And then if you want to know the elevation, your current elevation is this. If you want to know your current elevation, you would put the -3 into here, and then the function, the whole function itself will then give you your elevation. Well, anyway, your elevation is currently at 588, so you are currently here. The question is, in which direction should you climb in order to climb its steepest? So if you climb in this direction, then you're going to go downhill. If you climb in this direction, then yes, you are going uphill, but it's not that steep. You should have a gut feeling that you should head somewhere in this direction. If you head in this direction, then you will be climbing at its steepest. But then how do you know it's here? How do you know it's not slightly to an angle? There's a slight angle here. Or how do you know it's not in this direction? Well, basically I'm asking you to find the unit vector. The unit vector will specify the direction in which you should climb at its steepest. Okay, so find the unit vector in which the directional derivative will be at its highest. Okay, so press pause and have a go. Okay, so to do this we should look at the level. Let's look at the level curve at this location. So you are currently here at the moment. So looking at the level curve, so imagine your XY plane here, the origins here. So you want to head up to an elevation of 588. So it's you doing this. Head up up to 588, and then cut it, and then cut Mount Everest up. Well, basically put this into here, and then that will then give you your level curve. So if you cut where Mount Everest intersects with this plane, will look something like this. Will then give you your level curve. So your level curve will look like this. So this is 588 here. You are currently here. -3 in the x direction, +4 in the y direction. So you are currently here. So to maximize your directional derivative, remember your directional derivative is given by the dot product of the gradient vector and the unit vector. You're trying to find the unit vector. But we've seen this before. This thing here is the same as this. Well, the magnitude of your unit vector is always 1. This thing here is always trapped in between 1 and -1. So to maximize this, to maximize this, your unit vector should be in the same direction as this. We've seen this before, and I've explained this in the past. If you want to maximize this, then make sure the unit vector is in the same direction as your gradient vector. So really it boils down to you finding out your gradient vector. So your gradient vector will give you something that will be perpendicular to the tangent of the level curve, your gradient vector will give you some random vector, but then you want the unit vector, so you divide it by its magnitude. You divide it by its magnitude. You divide it by its magnitude. That will then give you your unit vector, meaning the direction you should climb in order to climb its steepest. Well, anyway, it boils down to us trying to find the gradient vector. So the gradient vector of our function, to work out the gradient vector of our function, find the partial derivative of our function with respect to x. So differentiate this thing here, partially differentiate it with respect to x. So that will then give us this thing here. Partially differentiate this with respect to y. That will then give you this. But we want to to evaluate it at our particular point at -3, 4. So that would give us this and this. So the gradient vector is given by this thing here and this thing here. So this is our gradient vector. So this is our gradient vector, but we want the units vector. So so at the moment this is our gradient vector here. This thing here will specify this vector here, but we want the units vector. So we got to get our vector divided by its magnitude. So its magnitude will be this thing squared plus this thing squared, and then square root the whole thing. It will be approximately 583. So to get our units vector, get our vector and then divide it by its magnitude. So that will then give us our units vector. So our units vector is in this direction. So this is your answer. You should be climbing in this direction. So going back to our diagram, if you want to climb at its steepest, you should visualize this in your mind. So you're currently at an elevation of this. So you find the level curve for that elevation. So your level curve will look something like this. So where Mount Everest intersects with our plane at an elevation of 588, it should look something like this, and grad f is always perpendicular to the tangent. So to the tangent of our level curve. So the tangent of our level curve looks like this. It's always at 90 degrees to our tangent of our level curve. So you should be climbing in this direction. Okay.